is Zach Rosenfeild. I have brought Roger Gu with me as well. He's going to go at the end. I think he's secretly hoping I am going to talk for so long we won't get to him. But we have a bunch of good topics today. We're going to open with an architectural overview, discuss the evolution of SharePoint, kind of get you in the right frame of mind. Move on to the #1 most requested topic that I get when I speak with customers, and that's disaster recovery, how we do it, how we make sure your data is always available. We'll talk a little bit about the challenges of running at scale, a little bit of an open and honest conversation, show you some real experiences from our customers in the service today. And then finally, Roger's going to come up and give you the full overview of throttling, protection, how we keep the platform up and running, and how that impacts you, especially if you're writing code. So, straight into architecture. We've been on quite a journey in SharePoint Online. I actually have the proud distinction of being the longest standing member of the SharePoint Online team. My journey actually started before this, but I was there on the first day and have been with it all the way through its evolution. So I like to explain the path we've been on. When we first shipped in 2011, we really just took the SharePoint 2010 bits, we wrote a bunch of code around it, and turned it into a cloud service. So the stuff we actually called SharePoint Online was mostly a wrapper on top of the on-premises service server bits. In 2011 to 2013, we really shifted our focus to automating. So the #1 cause of failure in a cloud service is human error. So taking humans out of the daily processes involved in running a service. From there, we really had to figure out how to grow. So we shipped this thing called SkyDrive for Business, which is now OneDrive for Business, a little name change in there. But it really took off, and with it came a bunch of new issues for us in terms of how the product works. This was the first time we really said, we need to go change what's underneath the hood and rethink how the storage platform works. This led us to the next set of technology investments that were cloud first. This is the first time we really said, how does the cloud work? What do other folks in cloud services do? How can we make our platform better and integrate that deep into the technology stack? And if you used the on-prem 2016 product at all, you may have seen us start to differentiate between features that were cloud only and some that worked on premises as well. And that leads us to where we are today. It's really been a focus on next generation technology. This is the first time when we've really said, not only are we going to rip out things under the hood and replace them with newer, better designs, but we're going to try and think innovatively about how we can do cutting edge next generation tech. This is stuff that Jeff was talking about at the keynote when he talked about how we've changed the storage platform. We've actually ripped out the inner pieces of SharePoint and replaced it with something more cloud-focused. We're also in a lot of places. I think Jeff called out the numbers, 54 data centers, over 20 regions. We are in a lot of places, and we're continuing to grow and expand. So as you think about the architecture we talk about, we're going to talk about it in a singular instance, but it is replicated all over the world and very heavily automated. There's too many of these things for us to possibly consider doing any of this stuff by hand. So with that, I'm going to take you back in time to that initial architecture. This is the original architecture when we shipped SharePoint Online, and I get a little bit of heartburn just looking at it. There's a lot of boxes on that screen. These are each individual roles and components that have to be rationalized, understood, thought about. Think about how does HA work? How do you do these different service activities? And it's incredibly hard at this scale. You should also see it as boxes of boxes of boxes. That's on purpose. Every single one of those has to be scaled independently, and this leads you into all sorts of tricky situations. So we evolved, and in 2016, the last time I gave one of these talks, I put a diagram that looked like this. Getting closer to what we have now, but still a set of roles and our first intro into some Azure integrations. So we took on Azure Storage to store user content. We're still running our own SQL service. We have 3 compute roles, bot, user, and in this diagram, a DCH, but an in-memory cache role. Those are the things that are actually interacting with users. So from there, I'm going to show you where we're at today. I wrote new architecture, but it's really just the latest architecture. You should think of it as we're constantly evolving and growing the system. But we still have browser traffic, app traffic, and third-party services. And these integrate with Microsoft through the Microsoft front door. So this is a routing tier for all Microsoft services. It's not something specific to SharePoint, but we integrate with it, and it's how traffic gets from users to the nearest Microsoft-owned endpoint to them. And from there, it can route into what we actually call the SharePoint Online service. And I draw this box distinctly to represent the things that my team is responsible for and the things that I'm going to talk to you about today. But there's more to Office 365 services these days. Inside of this, we still have those three roles we just discussed, bot, user, and cache. But we've actually started to build microservices. These are single function services that do common reusable tasks. These are all stateless services. They do things like notifications. They do things like image processing. This is where we do all sorts of processing on data, whether it's in delivery to a user as part of a video stream or it's generating a thumbnail. But the idea here is these are reusable services, and they're very lightweight. And then we integrate heavily with Azure. So we use SQL Azure, and we use Azure Storage. Jeff already shared this, so I guess I'm free to as well. We are the biggest consumer of Azure as a Microsoft product. So we are tightly integrated with the Azure teams in terms of how they operate, but we've also built a tier of technology on top of SQL Azure and Azure Storage, and we'll dig into some examples of that when we talk about disaster recovery. And then finally, there are O365-wide services that we integrate with. So these are features and functions that if you've been with us for a long time, you would have seen them in a SharePoint-specific instance before. So the auditing data, the e-discovery, retention, legal hold, they all had prior instances where they were SharePoint specific. We're trying to take all those things and make sure they're done at an O365 wide level, so we don't have to innovate independently in each and every O365 service, and rather we can all integrate with one set of services, and you don't have to keep asking, oh, does that work in SharePoint? How does that work in Exchange? Something way more exciting next door. Last bit. We also do have to interact with our own service ourselves. There's a service fabric column on the right. That is where the code that we write to manage the service lives. It talks to those bot servers, but so does the Azure migration pipeline. If you go to any of the Azure talks, they'll talk about how they've built a dedicated pipeline where we can manage the flow and provide optimal throughput. That all runs in sort of a parallel pipeline. So that's our basic architecture, but we really are the platform for file content and collaboration in O365. So we have integrations from users. So these are Word, Excel, PowerPoint, OneNote, Teams, your own custom applications, your own custom portals. They're all building services that interact with SharePoint content. And similarly, Office 365 security services, some of those O365-wide integrations, as well as third-party vendors such as CASB, DLP, AV. They all integrate into our platform and touch the files on a very, very regular basis. A lot of files, a lot of activity. So we needed to make sure this worked really well. So what we've done for the last 2 years is actually rebuilt our storage platform from the ground up. So this is what I was talking about in terms of ripping out the old and in with the new. And we took a different approach this time. I would just say, being totally honest, in previous releases of SharePoint on-prem, we would have said, we build SharePoint, there's other teams who do things in IIS and networking and the like, and they're going to figure out their part, we'll figure out ours. This time we said cloud service end-to-end. Everything matters from the corporate network into how we store the files on disk. And so we have worked with various partners or written the code ourselves at every piece of this stack, from the ISPs down to Windows and IIS. There are changes that have been made in every element to streamline the experience. I do want to call out 2 specific changes, though, in the stack. This is obviously the thing that we do the most with and have the most control over. We have changed how we store files. And this is important under the hood because it means that we are designing for a particular pattern of access that is dynamic, focusing on collab and real-time authoring, but is also designed for performance. And the simple model here, we take something as simple as a PowerPoint document. Inside of that document, you have slides, you have text, maybe you have an image, you have a video. Instead of taking them all together and putting them into one bundle of bits and storing that on disk, we actually understand and can uniquely reference any of those particular elements. So if you wanted to see slide 53, and maybe we should get you the text first, and then we'll go get the video that's embedded later, we can actually do that at a file stack level, and we can optimize for those scenarios and let all the different clients build the specific requests that they need into it. And then the second part is actually plumbing through the entire stack, an understanding of what you're actually doing with that content so that we can inform downstream parties like search to make smarter decisions on top of it. And so searches use this to their advantage. Again, Jeff mentioned this content push service. Content push service can actually take clues from the file stack into account and understand what the actual point of that content change is, and can use that on a priority flow. So here you see high, medium, low, and as appropriate. Those are cues that the search team has built to ensure that a user touching a file in a OneDrive sees that show up in seconds versus a user doing a batch upload during a migration. Maybe that's not going to be at the same speed. And again, if a dev on our team decides he needs to do an update and push a big change, that's not going to get in the way of those user interactions. So we combined all those things with the reach of the Microsoft network. It's a global network. And what this has enabled us to do is ensure that your content, no matter where in the world you are, and no matter where in the world your content is, you can have a great experience. So there's no penalty to collaboration, regardless of whether you and the person you're collaborating with are physically together. I can go through this topic for a really long time. I love the stuff we've done in perf. This is probably the full extent of it in this session. There was a session an hour or so ago, BRK 155. If you wished you could have heard an hour and gone into the details of how this works, the materials, I believe, will become available later, and I recommend you check that one out. OK, quick architecture summary before we move on to the deeper topics. We have a new storage platform optimized for co-authoring and for performance. We are a global and large-scale service, and we use that to our advantage in enabling great experiences. And then we are into the journey of replacing some of our older elements with a cloud-first, next-generation stack. OK, now we get to the fun stuff. Disaster recovery. First thing I always have to clarify when I talk disaster recovery is high availability versus disaster recovery. We're actually not going to talk much about high availability. I'll call out a few places where it's interesting, but for the most part, high availability is about component level reliability, and it's about handling regular failures. And just a quick example of what I mean by that so that we understand where the line is. If you have 100,000 hard drives, we have a lot more than that, but if you only had 100,000, 1% failure rate is a totally reasonable failure rate to expect. And that means, on average, you're going to lose 2.5 machines per day. Now, we also, in our service, take patching very, very seriously. We want to make sure we're always up to date. We take 10% of our fleet out during business hours, and as much as 25% of our fleet are getting patched in off business hours. The result is a whole lot of machines out of rotation, and some failures are going to be thrown into the mix. And so you have to understand and plan for the inevitable state of, if I only had 2 machines serving a purpose, there will come a time when one is getting patched and the other one fails. So this is why you have to deal with HA at a component level. It's specific to the problem. If you have state, you deal with it differently than if you're stateless. But there are many different strategies that go into the different components, and I'll hit on a couple key ones. What we are going to talk about is disaster recovery. And this is how we deal with truly catastrophic failures in the service. real examples of catastrophic failure that I've had the privilege of going through. Lightning striking a data center. That one wasn't even that long ago. We have also had someone unplug the wrong rack. There was an order to decommission a rack, and they, whoops, got one of ours instead of somebody else's they were supposed to do. So these are just things that we didn't plan on happening. We didn't know they were going to happen ahead of time. Nobody warned us. What do we do? So I'm going to show you a completely different architectural diagram than the one I showed you before. I'm sure it looks a little bit different, but this is going to help with the flow. But before I go through it, I do want to say it is the same components we talked about. There's a compute tier, a storage tier, metadata tier. So this is stateless compute, SQL Azure databases, and Azure Storage. And we're going to walk through what happens when you save a file into SharePoint and how that ties into our DR story. So the first thing is a user comes in through the front door nearest to them, and they're routed to the environment where their data should reside. That will get stored in a SQL Azure database. And SQL Azure will make multiple replicas, 3 replicas in total, synchronously written, so to ensure that that metadata is stored and always available. In parallel, it will write the blob contents into the Azure storage in the same region. So this is Azure regions, and this is all about speed. Local copy, easiest for us to go right to. In parallel with that, however, we will also write the same blob into the secondary data center. So we write the same blob into both. We read back enough information on those blobs from Azure and compare that to the information we have from the blob to make sure that all 3 are the same. All of that must happen before we tell you or your user, HTTP 200 OK. So we have written the file into 2 distinct physical regions. Azure uses a concept called erasure coding to provide essentially 3 replicas in each location, so that's your HA story, for a total of 6 replicas, all written before we ever say, we've got your file. In the read case, we also can go all the way to either location. By default, we will always go to the local location, but if we're unable to get a component of that file, or even if it just takes a little too long, we'll go ahead and reach out to the secondary location, and whichever one comes back first, we'll use that. So we use both Azure instances as active-active storage, which effectively, to sort of use the on-premises terms, gives an RPO of 0. We do use replication for our databases. We use the out-of-box SQL Azure replication. If you go look at their documentation, there's a bunch of information on this online. They will say that for their premium SKUs, where you manage your own DR, which is what we do, the replication estimation is less than 30 seconds RPO. Similarly, they will set up secondaries for that same content in the second data center. So what this means is when something bad happens, so when lightning strikes that data center, we can go ahead and reroute that traffic over to the secondary, which can talk to the replica of that data, which has been moved over by the SQL Azure team. And we can go ahead and talk to either of those Azure instances. If both are still available, we can do that. In the case where the guy unplugged the wrong rack, that didn't impact Azure at all. We could still talk to the original source. We could still talk to the local source. It really doesn't matter because we always talk to both of them during writes. So that's kind of the high-level flow. It actually feels a lot simpler on paper, but the whole process we're working with needs to fit into our goal of being a 4.9 service. 4.9s is 4 minutes and 23 seconds a month. It's not very much time, and fundamentally, if a human ever had to be involved, I mean, even just to pick up a phone or push a button or log into a corporate network, 4 minutes is never going to be enough time. So we really pride ourselves on shifting to an automated failover, and there's a couple of key steps we had to go through. First off, in order to be in this state, failovers have to be fully automated. If any human process comes into play, it's just simply not going to work. Second, we run on a principle where if no failure has occurred, failover has no impact to users. This is important because we want to do failovers all the time. And we never want you to know about them unless something actually bad happened. Obviously, we didn't know lightning was going to strike, but we did know when Hurricane Florence was going to hit the United States that it was potentially going to hit some of the data centers where we had customers running out of. So we went ahead and failed over out of those data centers to make sure that the primaries were outside of the range of the hurricane. And that means we don't have to have a failure impact to you if the hurricane does, in fact, hit a data center. So we can be preventive. And in fact, we run drills, and the net result is we do over 100 DR failovers every single year. So we do these very, very commonly, very confidently, and we want to make sure that we are always ready for when the real thing occurs. The other big piece is fail back must be equally painless. I interestingly always get this question of how do you handle a DR event, and no one ever asks this critically important question. Because if you were on a very old version of SQL, some of the versions we were on when we first launched this service, you could fail over quickly, but then you had to rebuild the secondary in this extremely time-consuming process that was very manual and took quite a bit of time, and so as a result, we were always nervous about doing a failover. You didn't want to fail over because the cost of going back, or really the risk of running without a secondary for a period of time, was too great. And so we had to make sure that fail back was equally painless, and this is where our partnership with SQL Azure has been super critical. So this is the part of the talk where I get into a little bit of trouble. I haven't seen my boss in the room, so hopefully it's okay, but I'm going to tell you about something that hasn't actually shipped yet, but we're working on. I think it's a good example of some of the evolutions that we are continuing to make in this space. You won't see it in a roadmap. We won't talk about it because it's not really something you see. It's something that makes my engineers' lives a little bit better, but it does speak to the overall strategy and where we're going. So today, if your environment is in one of these data centers, you and all of the other databases that are cohorted with you are all running on one data center side. So this means that the secondary farm is truly a secondary. It's just sitting there waiting for a disaster to strike the primary and for us to go over to the secondary. And I kind of liken this to keeping a spare car in your garage. You're just there just in case you have a problem with your first car. And yes, you can do some oil changes and you can do some regular maintenance, but in the end of the day, when something goes wrong and you need to get to work and your car is dead and you get into your secondary car, you don't really know that it's going to work until you turn the key. And so we think we can do better. We think we can actually route to both environments and process some environments databases on the right, some environment databases on the left, and actually run both environments in an active-active configuration. So this means we always know that the environments are working, and we always are aware that the environment is running before we do a failover. The other big change for us here is that it's a smaller failover unit. I know I said, hey, we do 100 failovers a year. Every single time, I still get a little bit nervous that it's not going to go quite that well, and its failure scope is so big that we're still just a little bit cautious, and our thresholds for automatically failing over are tuned to that level of risk. So as we reduce the scope of risk, we can be even less cautious about when we put these tools to use, and we can start to run them more often and more frequently. The final thing on DR, every time I start a DR conversation with a customer, I always have to ask, did you actually want to talk about all the slides we just went through and understand how we keep your data safe? Or did you want to understand how you protect yourself from the very real threat of viruses, from malware, from ransomware, accidental deletes, malicious admins, whatever the scenario might be? Your content also has to be kept safe. We do have some great tools here. I think the team has done some really cool things related to disaster recovery of content, and this is things like files restore. You can actually go back in time to anywhere in the last 30 days, down to the individual change. It's a great experience. If you want to learn more, there is a talk tomorrow, THR 002, Files restore in SharePoint and OneDrive, but it's going to talk about the whole disaster recovery process. It's 20 minutes. It's a well-spent 20 minutes if you have any questions about how this stuff works. All right, we hit on disaster recovery, how we keep your data safe. We talked how we're continuing to innovate. Active is just one of the innovations in this space. We don't get a lot of airtime to come talk to you guys about the cool stuff we're doing, but just wanted to give an example of one of the ways in which we're getting better every day. And then there are user-facing tools to help you with ransomware, to help you with accidental deletes and the like. Third topic, running at scale. This is where things get a little more real, and we'll talk to you about some issues we see in the service. I do have a big challenge every time I talk about our service because I can't actually tell you the total numbers. Powers that be won't let me share with you the number of gigs, the number of users, number of everything. But I can talk about a specific customer. I can talk about us, Microsoft, as our own customer of Office 365 and how we use the product, and use that as a proxy of how the service is growing and what's going on. So I've done this talk a number of times over the years. Spring of 2014, I was here in Vegas, and I got to show that MSIT had a whole 60 terabytes of data. And we had brought about 20 terabytes of this from on-premises, and the rest was organic data from the release of that SkyDrive for Business product. 2 years later, I came back, and it had grown by 10x. Still about 90% of it OneDrive for Business data, but continuing to show how organic content was coming off the hard drives and into the product. Last year, 2.3 petabytes of data, so technically slowing from a pure rate, but still very, very large numbers, and with that, continuing to grow by bigger numbers. And then in just the last year, it has doubled yet again. So this is just showing the Microsoft experience, but it should hopefully give you an idea of how things are growing, and especially since Microsoft is not one of the largest customers in Office 365, it's representative of the overall growth in the ecosystem. With that, we have to grow our service with you. Generally, however, figuring out where that growth is going to be, what sites are going to grow, which tenants are going to grow. A lot of tenants will set up a production, a test, a QA. We've got all these different tenants. We don't really know where that growth is going to come. So we've had to build a few tools that we use in our arsenal to grow with customers wherever the growth may be. Real quick, just two of them. This animation is walking through DB mitosis, where we take one database, we replicate it, and then we drop the duplicative portions of both to result in two distinct databases. So this is a process we use to grow our data sets while people are using them with very minimal downtime. When we first started using this process, it was a 4-hour read-only window. We used to communicate these long, long windows. Now, with the help of SQL Azure, we've brought this down to such a small number that we don't even bother telling you about it is in seconds. Similarly, we have a set of technology where we can move tenants. With the release of new data centers every so many months, we're often having to move people from one geography to another. We have multi-geo offerings where your users need to move between data centers. So we've had to build a set of technologies where we can move tenants between data centers in a seamless fashion. So now, shifting that same conversation a little bit, we do struggle a bit with understanding the growth of certain tenants. And what it really comes down to as we dig in over and over is legacy code. So customizations are great. We love seeing people doing interesting, powerful things with the SharePoint platform, and we want to make sure that we can scale for it. But we spend a whole lot of time helping customers dig through CSOM and dig through REST. So these are two legacy APIs that were really designed for rapid development, for quick onboarding, and for very simple single-user use cases. The result, though, is they're inefficient by default. And I'm going to kind of explain what that means. This is straight off the MSDN website. Here's how to make a REST call. It gives you all the items for a list called test. Seems totally fine. It works. It'll give you all the items. Problem number one, it's not telling you what parts of the list you want. So if you had a list with 1,000 items in it, it's going to give you 1,000 items. And I very commonly see portals where people are complaining about how slow it is, where there's a web part on the page that gets every item in a list and then shows you one of them. And then worse, this is SharePoint. It's not SQL. So SQL equivalent is select star. In SharePoint, we let you tie lists together. So if this call was made against a list that had a metadata lookup field in it, it has to actually go do a round trip to the metadata service for every row. So if you make that same call that does gets 1,000 list items, we're going to make 1,000 calls out to the metadata service to fill it in. So again, the goal is for it to work by default, to be simple to develop. But the result is it's inefficient. Second one, slightly more nuanced, but since I was going to put this on a screen, I had to mention it. Get by title versus get by ID. Get by title has to actually convert from a name to an ID. This is a couple extra round trips. Not a big deal, again, if you're writing a little app to do something once in a while. But if you want to build a major portal, or your vendor writing an app that's going to run millions and millions of times, this stuff starts to add up. Another quick example, 4 different ways to get a list of webs. The first one is the most obvious. I want to get all the webs in a site. And this call gets everything, things you would never need to know, configuration data, all sorts of system data. It gets you absolutely everything. And the result is it takes 1/4 of a second. We can keep optimizing by asking for less, or in the third row, you can actually see that at some point we decided that old one was inefficient. Now, because this is SharePoint and people take dependencies on how our APIs work, we often can't change the original behavior, so we add new APIs. And those new APIs are more efficient. And so you can see this progression from extremely inefficient to efficient. And again, if you're talking about a portal page, this is almost to a level where a user can perceive that difference, and that's one API call. But more important was the nuance there. We can't go back and change the behavior of the old APIs. So what we instead do is add new APIs. And so this is my open pitch to, if you can use the graph. The graph is our next generation cloud-first experience. I talk about things we've been investing in the last few years to be innovative and focus on cloud-first models. The graph is APIs on guardrails. You can't as easily do those bad patterns. It is safe and efficient by default. So the simplest solution there is to look at the graph. Similarly, customization impacts the user experience in the web pages. So we have a link, aka.ms/tune SPO. Talks about a bunch of different best practices. It won't go into the nuance of the APIs, but it's good to understand the legacy element. But it will talk about legacy features and functions that impact user experience. And I wanted to give a real example. This was not hard to find. I went into the service about 2 weeks ago. I found a site that had 500 unique users per minute. And the page load experience sometimes is about a second or two, sometimes is 30 or 40 seconds. The average here is 9-second page load. This is on the server, so you have to also add in the network and any sort of browser load and all those things. These are some pretty horrible experiences. I'm just curious, show of hands, has anyone ever had a page where they're like, sometimes it works great and sometimes it's just terrible? Quite a few. So we see this a lot. We see it so much, we built these best practices, and we built this, the first link on that best practice is for a diagnostic tool that if you run it, will find issues where it's causing these massive load spikes in the service that we don't know how to handle. It's not something we can predict, and it has a lot to do with how those technologies are built. If you run the diagnostic tool on that site, that customer actually has, I went and found their run, they have failed the big 4. These are the major 4 reasons for bad experiences. They cause giant queues in the service that the service doesn't quite know how to process. And so the result is long latencies and very sporadic, unpredictable load patterns. I went ahead, just as a proof point, found another site that I couldn't find one quite the same size. This one's a little bit larger, 725 unique users per minute, actually a kind of more consistent load pattern than the previous. They consistently see between 300 and 400 milliseconds of load. Yes, there's a spike there, but it goes from 0.3 seconds to 0.4 seconds. These are very, very small differences in load patterns. And the key difference, again, all the best practices being followed. This tool makes a big difference. These best practices make a difference. In almost every case, if you're having a performance issue, it's one of these things or the CSOM legacy stuff we talked about previously. OK, I spoke a bunch about what you can do. But this is more about what are we doing. But I had to set that up to explain this conversation. So it's a big challenge for us as we think about growth in understanding what is supposed to happen because it's the code we wrote versus what are you trying to do in your customizations. We struggle to understand what is by design in many, many cases. Do we know that your page took a really long time to load because our platform has an issue? Or did you create a dashboard with 400 widgets that you're going to load once first thing in the morning and never touch again? And you're OK with the fact that it took 30 seconds to open up. That was by design. We struggled to differentiate between these things. And so we've been working for the last couple of years on how to get a deeper understanding of this. So we're starting to use data to detect patterns, think about correlations, and really starting to think about tenant-level insights. So this is a dashboard of a particular experience we saw using our data. So you can see it's a little bit tough here. 2975 is what this particular customer is experiencing from a reliability. So this is everything. This is performance, their platform capabilities, the whole deal. What's our view of how they're working? And 2975 is a terrible, terrible number. But we also see next to it 96, so 396, also not good enough. And that's for the region. The whole region is actually not doing very well. And what we're able to see, though, is this customer has some unique correlations where when its experience drops, so does that of the entire region. And so we're able to correlate those things and tie it to a set of networking data. So really tiny font, don't try and read it. This is a mapping of where in the world all of our users are versus where in the world all of our data centers are. And we have expected speeds and patterns we expect to see between those. So what we actually found here was this customer was helping us find was a networking issue between Australia and South Korea where we had an inefficient pattern or path that we were taking all that traffic on. And in the old days, we would have ignored this and said, you know, that customer just has a lot of customizations. We can't really discern what's good load, what's bad load. Here we're able to use data to drive down and find real service issues independent of customer experience. So this also informs our best practices, so I'll plug the link one more time, aka.ms/tunespo. Go there, run the tool, give it a shot. If it does light up, we know those are challenges and will lead to those sporadic experiences. Some of these things will appear to work fine when you're developing because you don't have a lot of data or maybe you don't have a lot of users. They do generate real challenges when you try to launch at scale. Key takeaways. We're growing with you, but best practices really do matter. Please pay attention to them. If you see one of them that you're unfortunately not following today, figure out a path to get there. It will make a huge difference. And then we're using data to find issues, and we're going to continue to enhance and build upon that to provide new, better best practices as well as changes in our platform. So with that, I'm going to pass things on to Roger to talk about throttling.
Thank you, Zach. Hello, everyone. My name is Roger Wu. I'm going to talk a little bit about our protection platform, which we also call throttling framework. So first, let's talk about why we need the protection. So how we protect your experience from other app making mistake and then affect you. So as Zach mentioned, we have a long history of customization. We provide a great platform for applications. we support various different kind of applications running in our platform to support your business needs. So when it comes to running application at scale, application may see challenges. The first challenge is choose the right API. Zach mentioned a little bit. We have a different set of API designed in different stage, have a totally different mission. Some API is designed for ease of use, for quickly cook up application, support user interactive scenarios. But you also have applications you need to run large scale and high throughput, scan a lot of data across different sites in your tenants. So pick up the right API is critical for your application to be successful. The second is you pick the right API, you also need to have the right pattern. So when the application try to do a lot of things in a short period of time, usually we'll run into our protection system. We will back up the application, make sure the application won't generate too many contentions with the rest of the system, affecting your user using SharePoint. So we also ship a bunch of new features helping you move data around, moving data from your local drive to the cloud, like KFM. We also have features like helping you distribute your content to your users, like we call it team-side auto-mount. So those features can boost your productivity. It can also have a potential. It also has a powerful capability to move data around. So we generally will give customer guidance. How should you roll out this kind of a feature safely? But things still could happen. This is one of the example. So customer rolling out the no folder move. It start with 10% of the user, gradually everything works fine. But customer try to do the rest of the 90% of the user base in a single shot. Then we start seeing problems. It's not only adding pressure to your SharePoint, to OneDrive, but also in your own network, in your own environment. So that's how we need to think about how we can help customer protect those problems affecting you using SharePoint and OneDrive. So next one is abuse. We see that DOS, DDoS, and something even happen within your tenant. Your user may doing something unintentionally you may not aware of. This is a large customer. There's hundreds of users install a bad app. The app just start constantly putting 3 items from the user's OneDrive for Business at really high rate. It's about like the 50K per minute just for 3 items, exactly the same item. So our framework, throttling framework, caught this and throw it down. We talk to the tenant, and then me come back to say, thank you, we didn't realize this, and thank you for helping us protect our environment. So at the end of the day, the throttling framework has one mission, is make sure we pick the right traffic, we optimize for your end user interactions, and certain operations can wait, should run in the background, shouldn't take a decent amount of resource from your end user, we want to back them off. So that's the key. Okay, let's look at how the throttling framework works and when it kicks in. So first, we have read limits. This is to ensure the fairness between users, between apps within your tenant. So we have 2 models. The first model is user. So we give a fixed amount of the resource, which is a really, really high limit, generous limit. It's designed to make sure any kind of user interactive operation within a certain amount of time should run without any problem. We want to make sure users have a great experience when they're sitting in the other, when they're on the other end interact with SharePoint. The second one is app plus tenant. So this is the case you have a multiple application running your tenant. How do we make sure each app get their share and app won't compete with each other? The idea behind the scene is the same. So the application, when the application try to spread the load over the time, we'll get more resources out of the system. If the application tries to run against the limit or try to do tons of things in a short period of time, they generally will hit the limit. When it happens, we return 429. We tell the app back off and tell the app when you should come back. Generally, app should just honor this HTTP return code, and then try to come back later. Since generally will work in the next try, usually the throttling period is really, really short. We also have another type of throttling. This is meant to protect the service health. So even we have a protection in place to make sure application won't stress the system, sometimes it still have a short period of overload to the system. So when that happens, we have throttling framework in place to make sure the system has a chance to come back. It won't go down the negative path to have a broader impact. So when this happens, we generally return a different error code, which is 503. So the idea is that we give a different error code, we can differentiate what happens, what causes the application to be throttled. When they return 429, that means the application calling the service too aggressive. When 503 happens, we look at that carefully, we figure out what is going on in our system, we improve it to make sure this error will continue to job. So in the application runtime, regardless what error code you get, the idea is the same. You should honor this return code and then try again later. We always attach the retry after header. It will tell us how often you should come back. And it will give you the best chance to get work done. Okay, let's deep dive a little bit on the app throttling. Because the app throttling has a different type of scenarios. We actually create an option path and a default path. So for the default path, all the apps fall into this category. So we give a constant resource to the app. Again, this is a general, really generous limit, and most of the app won't run into it. We have telemetry to show us 99% of that won't. So this is designed for apps provide interactive operation for user sitting in the other end, doing work against the SharePoint and the OneDrive, using your application. So the recommendation is, if your app try to do a lot of work over the same, doing a lot of work in a short period of time, you should move to a different model. So we have this model that is designed for large amount of scanned app. So what is a scanning app? The scanning app tend to iterate a lot of content across different sites. They constantly crawl your tenant, the data in your tenant, try to understand what's the data. It includes like the CASB, DLP, or backup, or you build your own sync engine. It all could fall into the same category. So for this category, what we designed is a new quota. This is the quota model is we give you a limited quota during the tenant daytime. So when the tenant has user working in the SharePoint, the OneDrive, we tend to limit the amount of resource you can consume. So we can reserve the resource for the user interactive operations. We can also make sure that there's less contentions in the system. But during the nighttime, this is to the tenant local time, from 8 p.m. to 6 a.m. The system is less busier, and we have less user interaction happen in the system. We give you more resource you can consume. It will 5 times more than what you generally will get. Over the day, you will notice in this dynamic quota model, you will get more work done than the interactive. And the interactive model, which is default one, is really meant for the application that is provide interactive operations for the user, the scenarios for the user. So we classify certain app to this background category based on our knowledge, but it's a retrofit. So if you have an application you're going to ship, and you find out it's misclassified, please talk to our support team. We can help you on that. So I also want to deep dive on a particular operations that generate all the scan app tend to do. The scanning app generally want to know all the data in your tenant and try to catch up with all the changes happen. So we have 2 APIs to support the same scenario. but they actually introduced in different stage and they have a different mission. The first one is get changes, which is a CSON API. The other one is a Delta, which is a new API we ship in Microsoft Graph. So I have a really simple scenario, 2 users co-authoring a single document. So let's look at the API you choose and what the result it can generate. So the first API is get changes. Really, this API just iterate everything happened since you last time called this API. Let's say the user constantly adding the document will keep seeing the same document being changed by different users. If the application is not quite careful to consume this event and correlate them together to gather the changes for the same document once, it may end up doing a lot of work repeatedly for the same change. So for instance, it can end up just crawling the same document time and time again, but they all get the same document. So we have a different API, which is Delta. So we designed this API specific for sync scenario. So we know that when you come back, the application come back, it really just needs to know the current state of the document. So behind the scene, we correlate all the changes together and the attribute to each file. Then it will yield the more efficient application behavior. So application just gets the single file, we tell you what file is changed, and then you call another API to get extra change. Okay, so let's recap. When you design the application against SharePoint, we introduced the new API. That's our future, and we keep investment on. We have active investment on that. So if you have a scenario that cannot be supported by by the new API, user voice, we have a great ecosystem support team. Talk to them. We have guidance help app avoid the throttling, how to handle throttling in different throttling situations, what app should do, what you should optimize your application and versus what service hold ourselves accountable to improve. As mentioned earlier, we have scanning guidance. This guidance will talk about different pattern and what's the best pattern to scan data in the large scale. You will learn a lot of behind-the-scenes story from this guidance. Please take a look if you design the large scan application. Next is move the background operation during the nighttime. Because this is generally the service has more capacity, has more bandwidth resource for the application to run. Last is we have this alternative quota model. Move to that quota model. Talk to the support team. We can help you classify the app, move to the proper model. Okay, that's a quick talk about throttling. Here's the takeaway. Throttling is protection. It help our customer prevent any of these instances I mentioned from happening, affect the user experience. When it happens, it tends to be really, really short. So application generally just look at the retrieve after and try again. You will recover. Follow the best practice. It will help you build the best application in the ecosystem. So now I will head back to Zach.
Just hit the. All right, I think I'm just actually up here to close Roger Hangout, but thank you all for sitting with us for an hour. We talked about the evolution of the service, how we keep your data safe in SharePoint Online and OneDrive for Business, how we think about scale and growth, and obviously an emphasis on paying attention to the best practices and making sure that you're following those. It helps us help you. And then Roger went through the protection platform. We have about 5 minutes. We can take a few questions from you in the crowd, and we can hang out for a couple of minutes afterwards as well. So first of all, thank you.